Okay, in lesson 3.8 we're going to look at scatter plots and trend lines. Now we've already done some scatter plots in our calculator, so we're going to need our calculator today, right? And I'm going to show you how to do the scatter plots once again on those things. And then how to fit a trend line through those scatter plots to come up with an equation in slope-intercept form. So that's kind of the goal. Okay. So in our lesson, obviously, scatter plots, when you take and you plot points, right, they're either going to follow some sort of linear pattern. Now that's not perfectly a line, but it looks like it's a linear pattern. So when the y trends seem to be increasing as my x's are increasing, see how my y's are increasing as my x's are increasing? Or in other words, if I fit a line through those points, it's following a positive correlation or a positive slope. Okay? So this is really called a positive because the slope of this, if I were to fit a line through it, would be a positive slope. And it's a correlation in the data because it looks somewhat linear. It's kind of fitting into a straight line. So that's known as a positive correlation. So if I just plot information from the real world and it kind of follows a positive pattern, a positive linear pattern, it's known as a positive correlation. So what if I plotted points and then as my x's are increasing, my y's are decreasing, okay, and it follows a little linear pattern going down from right to left, then that would be a negative correlation. Why is it called a negative correlation? Because the points are kind of going downhill from left to right, or the slope of this line that fits through this data is negative. So that's known as a negative correlation. Now, if these are following a somewhat positive pattern, okay, that's a positive correlation. If these points are somewhat following a negative pattern, it's a negative correlation. And this line that I'm fitting through this is called a trend line. So what I try to do is I try to fit a line through the data where there's an equal number of points above and below. And it's really just a guess. So this right here is known as my trend line. And that trend line, like I said, is just a guess of a line that kind of looks like it goes through the middle of the data, doesn't it? Likewise, if I could fit a line kind of in the middle of this data, that line there is known as a trend line of the data. And what I can do is I can come up with an equation for this line, and I can come up with an equation for this trend line as well, and that's what we're going to look at doing today. How do you come up with an equation of this trend line in the data that's collected in the real world? And how do I come up with a trend line in this data that's collected in the real world? So that way I can make predictions. Because ultimately that's what math is about, is to make predictions. But sometimes when I pick data and graph it in the real world, it's just a bunch of points scattered everywhere. So what does that mean if I collect data and there's a whole bunch of points scattered everywhere? That just means that there is no correlation in the data. Does that make sense? Okay, it's not a positive correlation, it's not a negative correlation. I cannot use the data to make a prediction, in other words, right? So in that one, there's no point, there's no trend line I could fit through it. So there's no way I can make a prediction because it's just random information. That's like me saying your age and your intelligence. Well, what's the difference between your age and your intelligence? You're still as intelligent. You can do an IQ test when you're young and have virtually almost the same IQ as you did when you're older, right? I mean, I guess we can gain a little bit, but for the most part, there might not be a correlation in that data, right? Or it could be the color of your hair and your height. That's not a relationship, right? There's not a relationship in that data. Does that make sense? Okay, so it's just random things. So you could not fit a trend line through that. So those are the trend lines. We just got through talking about that. A trend line is nothing more than a line that's fit through a scatter point, and it's drawn near the points. And it shows some sort of correlation in the data if the data is a correlation. So once again, this trend line shows what type of a correlation in the data? Positive. This would show a negative correlation. Okay? And these trend lines are used to estimate values between two known values. Like, for example, if I want to know if this is x is 1, 2, 3, if x is 3, what's y? Well, I can figure that out because there's a point on the line at 3, whatever this y coordinate would be. But what about here? What about here? What about here? Well, I can come up with an equation for that line, and I can make predictions of what those values could be in between that based upon the trend line. Okay? Now, these lines of best fit, they have something called a correlation coefficient. Okay? So a trend line that shows the relationship between two sets of data most accurately is called the line of best fit. So if I just did this with pencil and paper, that trend line is just an estimation. But I can use calculations in my calculator to do a line of best fit. And that's what this is saying. A graphing calculator computes the equation of the line of best fit using a method called linear regressions, which we've already done. Haven't we done that? Okay? And that's what we're going to use again today. But when we do a linear regression, there's something called a correlation coefficient in our calculator. And it's really indicated with an R in our calculator. And that R tells us how closely the equation models the data. If that R value is a -1, or if it's a +1, it means it fits through every one of these little data points perfectly. It would go through every single one of them. So that would look something like this. If I plotted a point, plotted a point, plotted a point in the real world, and then I fit a line through it and it goes through every one of the points perfectly, my R is a 1 if it's a positive sloping line. If it went through every data point perfectly and it's a negative sloping line, like see how it goes through all 4 of those points perfectly, then my R value would be a -1. Do you understand that? Now, do these trend lines fit through this data perfectly? No. So my R value would not be a 1, but it could be something close to 1. So it's maybe approximately a 0.89 or something like that. Isn't that really close to 1? But it's not exactly 1. And this R value, since it's a negative sloping line, would be close to 1 because these data points are pretty close to the line, aren't they? But they're not right on top of it like this one, where my R would be exactly a -1. Here my R is exactly a +1. But since these data points are kind of off the line, it's going to be something like a 0.91 or a 0.92, something like that. It's going to be close to 1, but not exactly 1. You understand what I'm saying? And that's what this is showing you. When I have an R value that's 0, there is no correlation whatsoever in the data. But as my R value gets closer to 1, it's getting stronger to the positive side. And then if my R value is over here to a -1, it's getting stronger to a negative correlation. And that also corresponds to the slope of your trend line. If my trend line is negative, it's a negative correlation. If my trend line is positive, it's a positive correlation in the data. Now, how do I come up with that R number? Your calculator will do it for you. Okay? So you don't have to worry about how do I calculate that. Your calculator does that for you, and it's called a linear regression in your calculator. That's all that that's talking about. So let's look at all this information and see what it means. So in problem number 1, we're going to make a scatter plot, and we're going to describe its correlation. And the only way that I can describe that correlation is to do a linear what? Regression. So that's what we're going to do today. Okay? So let's go ahead and do a scatter plot of this information. Now there's a couple different ways of doing a scatter plot. Okay? What we're going to do is we're going to do it in our calculator. And it's already given to you here though, right? So if we wanted to do it with pencil and paper, and I've already got it, here's what I could do. I could just get a ruler and kind of connect the dots as accurately as I can, right? Except I'm not going to get an R value if I do this, right? So I'm just going to say I'm going to try to get it to go through as many of these points as I can with an equal number above and below. So I'm going to do a trend line that looks like that. That's what I think the trend line would look like. What about y'all? I don't know. Yours might be a little bit different. But I can come up with an equation of this with pencil and paper by using this point and maybe this point or this point because it looks like my trend line goes through those 2 points. And I could do a linear regression using those 2 points, or I can use these exact values and plug it into my calculator and be more accurate. So that's what we're going to do today, is we're going to let our calculator do that. So we're going to make a scatter plot of this, and we're going to fit a trend line through it. So how do I do that? Well, step 1, we got to make a scatter plot by going to New Document, which is number 1. Don't save your last one. Okay, and then we're going to add a graph, right or wrong? we got to enter the data in first. So I've got to enter lists and spreadsheets first. Now, what do you want to title this? Altitude and temperature? You can, but you put that in there and type in altitude and put this in here and calculate and type in temperature. I wouldn't do that because it takes too long. Just remember, X is going to be my altitude and Y is going to be my temperature, and it's so much easier to calculate with. So title this as X, and remember that means altitude, and that's my independent variable, and my temperature is my dependent variable, because the temperature depends upon the altitude. And then just enter in your X values. There's a 0. There's a what? 500. Enter, then 1,000. And then a 1,500. A 2,000. 2,500. A 3,000. Just enter the rest in now. 3,500. 4,000. 4,500. 5,000. Okay, and then just enter the corresponding Y values. Okay, so my Y value would be 59 degrees, 59.2, 61.3, 55.5, 41.6, 29.8, 29.9, 18.1, 26.2, 12.4, and then instead of 0.6, looks like it's 0.6. Okay, got to hit enter though. Now all my data, okay, fit on there. And then what I want to do is I want to look at that data on a scatter plot. So we're going to add a page so I can just look at the points. So you remember how to add a page? Control what? Add a page. Now we want to add a scatter plot. Okay? So do y'all remember how to add the scatter plot on there? We're going to add a graph. Okay? And then I'm going to go to menu, graph edit entry, and then we want to graph a scatter plot, which is 6. Okay? And then what was X? It's X, and Y was Y. See, I didn't type in altitude and temperature for a reason. It's easier to do the scatter plot. And there it is. I don't see it though. You remember, how can I see it? How can I zoom in just to those data points to make it look like this? Go to menu, window, and then we want to zoom into the data, which is number what? 9, and just hit enter. There it is. Doesn't it look like theirs? There's a scatter plot, right? So we've already done that. This is like the 3rd or 4th time we've looked at those. So this is just another way of doing the scatter plot. Everybody good with that? Okay, now, what I want to do is I want to go back to this page. So let's go back to this page right here, and I want to come up with an equation of a trend line that goes through those data points. So what would this equation of this line that would go through the data points be? Well, my line is just a guess, right? This one is going to do a calculation called a linear regression that's going to fit it the best way possible through these points, where it's an equal number above and below as accurately as it can get it. So to do that, I'm going to go back to this page. So how do I go back to this tab over here? I just hit Control left, or you could have used your mouse and put it over there and just hit enter. Go to an empty cell. Let me go back over here. Go to an empty cell and hit menu. Menu. And then we're going to go over here to statistics, which is 4. We've done this before. Then where do I go to? Stat calculations, which is 1. And I want to do a linear regression. Which one? Slope intercept form. That's number 3. Very good. And then X is X. And what was Y? Y. And then just hit enter. And there's the equation for it, right? So what is the equation for this? Well, if I had to write it down, okay, in order to come up with an equation for this trend line, and if I said, y'all tell me what the equation of the trend line is, it didn't ask for that. It would be what? Y is equal to, what's the slope? Because remember, it's mx plus b. What's the slope? Plug in the slope. It is negative 0.0122 times x plus my y-intercept, which is what? 66.2818. Right? Everybody follow that? Isn't that an equation for the line? And I can make predictions based upon that if I could call up a table. Right? So what if the temperature, or what if the altitude is 250 feet? What if the altitude is 789 feet? How do I figure out what the temperature is based upon this equation, this function rule? Okay, so let's go back over here to this graph page. So hit Control right. Okay? And then what I want you to do is to hit Menu. And then go to number 3. Menu 3. Once you get to that scatter plot. Okay? And then I want to go to number 1. Right? I want to rechange it back to not a scatter plot, but to functions. And then why did it start at F2? Because it already graphed it in F1. Whenever you did your linear regression, it already saved that into your function editor in 1. So if I go up 1, there's the same thing I just got through writing down, except more accurate. Negative 0.0122 times x plus what? 66.2818181818 that just keeps repeating is plugged in for me. And to graph it, all I have to do is push enter and look at the line. It's going to go through the points. Almost the same as our line, right? Except this did it with actual calculations. Right? We just guessed our line. So there's the equation of the trend line that models that data. Now we can use it to make predictions if we had to. Okay? So let's see what the question is in problem 1. The table shows the altitude of an airplane and the temperature outside the plane. We made a scatter plot and we did a regression. Based upon the regression, let's answer the question. It says, what type of relationship does this scatter plot show? What would it be? Is it a positive correlation, negative correlation, or no correlation? The temperature outside the plane tends to decrease as the altitude of the plane increases, so we have a negative what? Correlation. And we even have a line, right, that goes through those data points. Now here's my question based upon this correlation stuff. How good of a fit is it? How good does this line go through the points? Well, let's see. Let's go back to that page and see if we have an R value. So hit Control left. Or just push your little cursor over there if it's being ornery. Right? And then let's look at our R value. So let's take this and kind of scroll down. There's an R squared. There's an R. See that R? That R value is my correlation coefficient. It's close to a -1, isn't it? That's like a negative 0.96 is 400ths away from a -1. So if I said, is this a very good fit through the data? What would you say? It's a very strong correlation. It almost goes through it perfectly. If that was a -1, it would go through the data perfectly. So not only do we have a negative correlation, we really have a strong negative correlation. It's not perfect, but it's really, really strong. It goes through those data points really good. So this line, this equation, would be a very good equation to make predictions in the real world. Like, let's make one prediction before we move on. Okay, so let's go over to our graph. So go Control right. And then I want to predict what the temperature would be if the altitude is 783 feet. How do I do that? Add a table. So go to Control T. All right, and here's my temperature, right? What if it's 783? Well, how do I get to 783 really quick? Do I got to sit here and scroll down all day long? No. Hit Menu. Menu. Go down to Table. Click over to the right. And let's edit Table Settings, which is 5. Where do you want to start the table? 783. That's what I want to know. And then just tab down and go to OK. That's what that means. Let's start it at 783. Oh, and what would the temperature be if I'm 783 feet above the ground level? Be 56.7 degrees, roughly. You understand? So what if I wanted to know what the temperature is at 893? Can y'all do that real quick? What do I hit? 893. Do I just scroll down to 893 or just go to menu whenever I'm on the table? Go to table, click to the right, edit table settings, to what?
893.
893. Is that what I said? And then just tab, 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 and go to OK. What would the temperature be then? What would it be? 55.4 roughly. 55 degrees roughly. Everybody get it? Okay. So that's a lot of information in one problem. Let's go to the next problem, B. Now in this one we're just going to remediate it. And we're just going to make a scatter plot and make a prediction. Is it a negative correlation, a positive correlation, or no correlation? We're not going to do the regressions in this one. Okay? So I just want to know what type of relationship does it show. Is it positive, negative, or none? So let's do this again. Let's just do a scatter plot. So we're going to go to New Document. Don't save my last one. And we want to do a scatter plot, right? So what we're going to do is we're going to do what? Add the lists in the spreadsheet. Title this as dollars spent is going to be X. The gallons bought is going to be Y. So I'm just going to go X, Y. So title that column, the X column, the Y column, and then enter in all the X coordinates, which would be 10, 11, 9, 10 again, 13, 5, 8, and 4. And then let's go up here and enter the gallons that you bought. 2.5, 2.8, 2.3, 2.6, 3.3, 1.3, 2.2, 1.1. Okay? So as I spend more dollars, what's happening to my gallons? It should be increasing logically. Let's see if that's the case. So we can do a scatter plot. Now I'm going to show you another way of doing a scatter plot. So we're going to go to Menu, Add a Page. So that's Control Doc. And then instead of going to add a graph, another way to do a scatter plot, if I'm just seeing if it's a positive correlation, negative correlation, and all that other stuff, where I'm not having to fit a trend line through it, is just to go to 5. Add Data and Statistics. And it's plotted for you. Except which one's the X coordinate? We said X is dollars spent. So go down here and click that as the X. And then my Y was the gallons, so click over here. So just take your cursor over there and click the middle of your screen and change that to Y. What type of correlation is that? Looks like I can fit a line through it and it'd be a positive sloping line. Okay? So what would that be if we did it using our technology? Looks something like that. So it would be a positive what? Correlation. Believe it or not, there are questions on the EOC that's pretty much that simple. But in most cases, what they're going to do is they're going to have it plotted already for you with a line going through it saying make a prediction. Okay? But we need to understand that concept first. All right, so let's look at B. Consider the population of a city and the number of letters in the name of the city. Okay? Would you expect a positive correlation, a negative correlation, or no correlation? So what are we considering? The population and what? The number of letters. The number of letters in a city's name and its population. Would that be positive, negative, or no correlation? What do y'all think? There's not a correlation in the name of a city and how many people are in it. I could have a name of a city that's very small and it doesn't have any impact on how many people are in it. So basically I would just have scatter plots everywhere and that would represent what? No correlation in the data. Okay? No correlation. That's how you spell correlation. You understand? Why? Because population is not what? Dependent on the name of something. That's just saying, that would be like me saying, hey, if your name is Bob, you're short. But if your name is William, you're going to be tall. That has no correlation in your name and your height, just like there's no correlation in population in the name of a city. Okay? Understand that part so far? Correlation in data. Let's go to problem 2. What I want to do in problem 2 is to write an equation of a trend line. So to come up with an equation of a trend line without pencil and paper, we're going to use technology for this. We've already done it with pencil and paper in the last lessons. So how do I make a scatter plot of the data at the right and then fit a trend line through it? Okay? So step 1. So in this problem, it says we're going to make a scatter plot of the data at the right. What is the approximate weight of a 7-month-old panda? And we're going to make a prediction of what panda is going to weigh when he's 7 months, because there's no value for that. Now, we could guess it's somewhere between 24 and 37, right? And I'd say if we guess, what would be a good logical guess? The span of that is what? 13? So maybe 7 more than that. Would you say about 30 what? 31? Okay. If we guess, we'd say, hey, 7 months about 31. Now, let's do some math calculations by doing a regression in our calculator to see if that's really a good guess. Okay? So based on the data for the first 12 months, let's predict the weight of a 15-month-old as well. So what's the weight of a 15-month-old panda now? Could we still make a prediction outside the data? You know what that's called? If we're making a prediction outside the data we're given, it's called an extrapolation. If we're making a prediction inside the data, it's called an inter, like inter, I-N-T-E-R. Inside kind of is I-N-S-I-D-E. So it's called an interpolation. This is called an extrapolation. Extrap. That would be E-X-T-R-A-P-O-L-A-T-I-O-N. Extrapolation is outside the data. We need to make a prediction there as well. See, that's not as easy to do because I can't just approximate it being in the middle of these two. So what can we do? We can come up with a trend line. That's what we're going to do. So let's enter this data in that we're given to our calculator, and let's do a line of best fit. So let's go to our home screen, new document, don't save my last one, and then let's add the list of data into our calculator. Now remember, X is the age of the panda. Y is going to be the weight. So we're just going to title that as X and Y. Now once again, if you wanted to put age and weight, you could. I'm not going to do that. It just takes longer. And then just enter in your data. When it's 1 month, 2 months, 3 months, 4. Then it goes to 6, then 8, then 10, then 12. What was the weight when it was 1 month old? It was 2.5 pounds. Then 7.6 pounds, 12.5 pounds, 17.1 pounds, 24.3 pounds, 37.9, 49.2, 54.9. Y'all follow? All right, let's do a line of best fit through those data. I'm not going to do a scatter plot right now. Let's just do a line of best fit. Okay? So how do I do a line of best fit? Go to an empty cell and then hit what? Menu. What is an equation of a line that goes through those points as accurately as possible? We're going to go to menu. Then I go to statistics. Then I go to what? Stat calculations. And we're going to do a linear regression in slope-intercept form. And what is it? So I hit 3, and then it's going to ask me, what did we title X to be? Did we title it to be age? No, we just said it was X. What did we title the Y coordinate to be? Was it the weight? No, we just said it was Y. And then just hit enter, and it's going to save it as an equation of a line in the graph as F1. So there's my equation. So what if I wanted to come up with the equation for this? What would it be? Y is equal to 4.9. Let's just round it to 1 decimal place. X minus the y-intercept. Remember, it's mx plus b. So I just plug in the slope for m and the y-intercept for b. So it'd be minus what? 2.5. And that's my slope-intercept form. And I could use that to make a prediction. But if I wanted to use this more accurately, how could I get a better prediction and use these exact numbers? And first of all, how good of a fit is it through the data? What's your R? It's almost perfect. It's 0.996, which rounds up to be 1, right? It almost goes through every point perfectly. Let's see a picture of it. Let's see a picture of that trend line going through those points perfectly. So we add a page, hit Control, Doc in your calculator. Add a what? The graph. It's already graphed for you. Go up 1, and look how much more accurately it puts it in your calculator. We rounded it to be 4.9 in pencil and paper, but it's really 4.9214611872146146x minus 2.5484 whatever. It's going to put it in there more accurately. So just hit enter, and there's the line to make a prediction of how much this panda is going to weigh given its age over time. You got it? Now how do I see those points? Right? So to see those points, just hit menu, graph edit entry 3. Where do I go to see the points? The scatter plot. And what was X? It was X from our table. What was Y? It's Y from our table. And just hit enter. There are the points. I don't see them. I don't see them all. How can I zoom in just to those points now? Menu, window, very good, which is 4. And then zoom into the data, which is 9, or data, however you say it. And there's a picture of it. There's a picture of my scatter plot and a line that goes through it. Look, doesn't it go through those points almost perfectly? Look, it goes through 1, 2, 3 perfectly, 4 almost perfectly. This one's off a little bit. This one's touching the line. This one's off. This is still kind of touching it. Now we can make predictions. Right? What was our prediction for 7 months? Okay? So at 7 months, which is what the question's asking, the panda will weigh how much? I don't know. Let's see in our what? Table. So how do I call up the table? Control T. Very good. And then I'm going to go over here to not 4 months, 5 months, 6 months, but 7 months. The panda is going to weigh about what? About 31.9 pounds. Round it to whatever place they say to. If it said round it to the nearest pound, it would be a what? 32 pounds. If it said to round it to the nearest tenth, it'd be 31.9. If it said to round it to the nearest hundredth, it'd be 31.90. So just follow the directions. Now, we had to make one more prediction. See, that's called an interpolation because it's inside the data. What if I wanted to do an extrapolation and find the data outside, or find the prediction of the weight outside of the data, and go to 15 months? At 15 months old, how much is this panda going to weigh? Yep, at 15 months it would be about what? So let's say I wanted to round it to the tenth place. 71.3 pounds. You got it? So we can make predictions in the real world using some technology now. And that's really what math is. Mathematicians have to make predictions. If you like math, you can get a job as a person that makes predictions for insurance companies. Okay, about what's going to happen in the future based upon data that they collect. All right, so let's look at problem 2. Let's see if we can do this one. Write an equation of a trend line. And we're not going to do this with pencil and paper. Let's do it in our calculator. So, how do I write the equation of a trend line? Well, let's follow the directions. We're going to make a scatter plot. We're going to draw a trend line through it and write its equation. Right? Using technology. So, we're going to make this scatter plot in a calculator. How do I do that? New document. Don't save my last one. Okay, add what? Lists and spreadsheets. So what's X going to be? Is it my age or my body length? If I'm ever given a table that's going from left to right like this, age is my independent variable, and my dependent variable is going to be body length. All right? As you get older, your body length increases, so it's dependent upon your age. All right, well, obviously, it's going to get to a certain height and stop, right? If you're 100 years old, you're not going to be 100 feet tall. because you're going to eventually stop growing. But we can use this to make reasonable predictions based upon the age of a person. Normally stops growing probably before they're 20 years old. Okay? They'll probably flatten out, really, in most cases, like girls probably flatten out about 17, 18. Guys sometimes grow to be 19. So it just varies. So it's not an exact science, right? These are just kind of estimations anyways. So we'll just title it as X and Y. And X is my age for this panda. And it's 1 month, 2 months, 3 months, 4, 5, 6, 8, and 9. And then what was the body length? Not the weight this time, but how long was it when it was 1 month old or 2 months old? Okay, so at 1 month it was 8 inches. Then 11 point what? 75. Enter your next data point, which is 15.5. 16.7. You already got it entered? Make sure you're doing it. Because me, I know how to do it. I don't want to waste your time. I want you to know how to do it. All right, and then what do I do to come up with a trend line? Come to an empty cell and hit Menu, Statistics, Stat Calculations, which is number 1. And what type of a calculation are we doing? A linear regression. So X is, what do we title that? X to be? X. And Y is? Y. Okay, and then tab over and just hit enter. And you're done. There it is. What's the equation of the trend line? Let's approximate it to 2 decimal places. So Y would be equal to M. What's M? 5.3 X. Right, plus my y-intercept. My y-intercept is a 6.72. You follow? How good of a fit is this? What's my correlation coefficient? My R is equal to a 0.994. So this would be a good what? Positive, okay, correlation. It's really very good. It's really, really strong because it's almost perfectly 1. Doesn't go through the points perfectly, but it is a very strong positive correlation, which means it goes through the data points really good. And you can see that visually. How can I see that visually? Add a page and look at the graph. So go to Control, Dock to add a page. And we're going to add the graph of that function rule. This 2.53 roughly, X plus 6.72. So I got to go up 1 after I hit graph, and then just hit enter so I can see the F1, and there's a picture of it. Now it's not a very good picture with my data points, so how do I add the data points in? Remember how to do that? What do? Everything is from what? Menu, Graph, Entry, Edit. We want to enter it in as a scatter plot, which it's already done, so I got to go to 3. You got it? And then I go to scatter plot, which is 6. And then X is X, Y is Y. Enter. There's all the points. I don't see them though. Because they're way up here, right? This Y only goes to 6. My first point was at 1.8, right? So there's a point right here, 1.8. I just don't see it right above that. Probably somewhere in the white. How do I see them all? Change your window. So go to menu what? 4. And what do? Go to zoom into the data from the lists. And there it is. That's a good picture of it. That's a pretty good graph, right? See how it goes through almost all the points perfectly? How good of a fit is it? Well, my R is almost exactly 1, so it's a really, really good fit through the data points, right? They're not off of this line very far at all. The more that these data points are spread out from the line, the more that's closer to 0. Right? We talked about that earlier. So, what's the body length of a 7-month-old panda now? We use our trend line. Use this line of this equation to come up with a prediction of how long it would be at 7 months. So at 7 months, the panda is how long? Is blank inches long. Well, how do I do that? Control what? Call up the table. You don't have to go to Control T to get the table. You know everything is on menu. You could have went to menu, and then you could have went to table 7, and you'll call it up that way as well. The only difference is it says, how do you want to do it? I'm going to do it as a split screen, so that's 1. And it even says, hey, you should have done Control T. That would have been faster. And then just go to 7. At 7 months, how long would the panda be? Let's round that to the thousandths place. 24 point what? Look, once I put my little cursor on there, see how more exact it gets it here? This approximates it to the thousandths place. But this one will go, if I wanted to go to the millionths place, right, I could round it to the millionths place. So I can get more accurate if I look down here. But this is already rounded for me to the thousandths place, so it would be 24.402. And we can answer questions from it. All right, let's answer this question. B. Do you think you can use your model to extrapolate? Remember how I said extrapolation means outside the data? The body length of a 3-year-old panda. Well, how many months would that be if it was 3 years old?
36.
So do I want to try to figure out how long a panda would be at 36 months? Could I do that?
Yeah.
You think so? Okay, think about your dog. How many has a dog? How many of you guys have a dog that's 3 years old? When did that dog stop growing? Is your dog still growing? Your dog ain't still growing anymore, you know. When that dog was about 1 year old, it stops growing. Usually a dog at the age of 1 is already at its full size. Most of them before that. Pandas are the same way. So do you think you can really use your model to figure out that? Just like us as human beings. I say, hey, we stop growing about the age of 17, 18, 19 years old, right? The same way with this panda, except it's 3 years old. They grow faster. They have a shorter lifespan than we do, too. Right? So, no, you cannot use this data because why? It stops growing usually around 1 year old. Okay? Just like a dog. Think of it that way. Or eventually it's going to stop growing. Okay? So you could say it either way. Eventually it's going to stop growing, or possibly it's probably going to stop growing after a certain time, which may be 1 year old. I'm guessing. Okay? Not real sure about that. It could be 2 years old. Problem 3. Finding the line of best fit. We've already been doing this. Okay? We're going to find the line of best fit in our calculator for this college tuition problem. We're going to use a graphing calculator to find the equation of the line of best fit for this data at the right. And what's the correlation coefficient to 3 decimal places? Describe it as a strong correlation coefficient and use the line of best fit to estimate the cost of attending in the 2013 or 2012-2013. Right? So we want to figure out that right after we come up with an equation of a line of best fit. So let's do our equation of a line of best fit real quick. Here we go. So I'm going to go to New Document. Don't save my last. Add lists and spreadsheets, and I want to enter this in. New, no. Add lists and spreadsheets. So I want to title this as X. Title this as Y. And then let's enter a data. So here's what I'm going to enter. 2000, 2001, 2002, 2003, and so forth. So my first year is going to be 0. And then a 1. Enter. 2. Enter. 3. Enter. 4. Enter. 5. Enter. 6. Enter. And then enter the cost of the tuition at that school. In 2000, it was $3,508, $3,766, and then $4,098. We'll stop after this problem. 4645, 5126, 5492, and then 5836. So there's my cost of the tuition. See how it's increasing over time? Well, how good of a fit is it? What's an equation to figure out what the population is going to be or the cost is going to be in the year 2012-2013 school year? So I go to an empty cell. What do I do to come up with a line or a function rule for this? A line of best fit, a trend line. Hit Menu, Statistics, Stat Calculations, which is 1, and I want to do a linear regression, which is 3. Then this screen's going to come up. In slope-intercept form, what was my x's? That was x. What was my y's? That's y. Right? And then just hit enter. So what's my line of best fit? Y is equal to, let's just round it to the nearest whole number. 409 what? X plus, what's my y-intercept? 3,410. You follow? That's my line of best fit. Now, it said to round it to the nearest hundred, so I guess we need to round it to the nearest hundred. It would be 409 point what? 43x plus 3410.43. That's my line of best fit. Now, what's my correlation coefficient? You got to scroll down here to see not my r squared, but my r. And it said to round that to 3 decimal places, it would be 0.99 what? Y'all tell me. All right, that 9 tells the 5 to go up to a 6, which is a strong what? Positive or negative? Positive correlation. Now, last part. Use that to figure out what the tuition is in the year 2012. What do? Control, add a page, add the graph. It's already there. Hit enter. Okay? Now it looks like a straight up and down line. It's not. And then go to the table. So go to Control T. Here's 2001, 2002, 3, 2005, 2006. I need to figure out the population in the year 2000 what? 12. Not the population, but the cost of tuition in the year 2012 would be about what? And we'll be done. $8,323.57. Okay? That should be money. Sorry. You got it? Okay, that's the first part of the lesson. We'll finish this up tomorrow.